Good afternoon, Arun here. Good afternoon, Suresh. Can you hear me?
Good afternoon, Abhishek.
Yeah, Suresh, am I audible?
Yeah.
Okay, okay.
Abhishek, Aranjit.
Yeah, I'm there. Abhishek, I think he's on mute.
Okay. It's Aranjit, right?
Yeah, I'm Arunjit. Yeah, I'm there. Yeah.
Yeah, I can see that. So my audio is also very clear, right?
Yes, sir. It is clear, sir.
Okay, right. That's fine.
Sir, you can share your slides.
Yeah. Hello?
You can share your slide.
Yeah. Sure.
Yes, sir. Good afternoon, sir. This is Jalal Sarkar, sir.
Hi, good afternoon.
Good afternoon to all participants. So now we have a talk from 2:30 p.m. Sir is basically discussed in the topic of cloud-based IoT and IoT communication protocol. Mr. Suresh Dantam. Mr. Suresh Dantam is the Vice President Technology, Techsys IoT Lab, a unit of Techsys Automation Private Limited. He obtained his BTech in Electronics and Communication from Sri Krishna Devaria University AP and Diploma in Business Management from Business Expresses, UK. He has overall 20 plus years of experience in the technology field with primary focus on electronics and their application. So Sir is very experienced and he is our industry expert. So now I invite you, sir, to deliver your lecture, sir. Please come forward.
Thank you, Abhishek, for giving an opportunity to me. It's my pleasure to share the latest technologies that is happening around with respect to IoT. So let us start this session. So basically, in fact, the time is around 1.5 hours is very too short for the cloud-based IoT and IoT communication protocols to cover the most of the topics. Anyway, I will try to do the justification to enrich more technical reality. So I have divided it into the 4 parts. It's just we talk about some basic communication protocols in the first part, and then we'll go with the IoT communication protocol. What are the little bit more exclusive to the IoT or embedded communication protocols? And then we spend some time on cloud-based communication protocols and what are the things that are there. And finally, I'm planning to give some kind of the demonstration, hands-on demonstration on the cloud tools itself, so that you will be having more motivation and interest to go forward. Okay. Just have spent a couple of minutes on from the fundamental point of view, what is the protocol? It's just a communication between the two kinds of the points. So it's a developed and it's used by anyone. Actually, it's a general term. So for the protocol definition and all those things, it's our prerogatives that we can define our own kind of the communication, any kind of things. Let us say you can see protocols when you have the prime minister of a nation visiting to the another place. He has some certain kind of the protocols. When a governor of a state visiting to another place, he has some different kinds of the protocol. That means it's a kind of the communication, how we establish, securely deliver the data and securely establish the communication so that the transformation of the data between the two nodes or between the two endpoints or between the two systems or one to many systems can happen more smoothly actually. So that's how we can define as the protocol. It's just a fundamental, I guess most of everybody knows of it. So, but I'm just going from the fundamental point of view. So when it comes to the IoT, we have our own kind of the specific protocols like HTTP, FTP, MQTT, SMTP, Ethernet, Wi-Fi, and all those things. These are our protocols that we concentrate more on from the IoT perspective. Okay. So fundamentally, all these protocols and communication layers, when it comes to the network, so we just take the reference from the OSI layers, that is the open system interface layers. I guess most of you know about all these things. I will not explain it. I just put a slide in terms of the saying that when we start from the fundamental and go into a little bit more deep. So we are not deriving on our own actually, we are taking the reference from the open system interface layers only that are there for the last 5 decades, and most of the network layers are developed around it only. So that's fundamental. So we just take the mapping of our IoT protocols also from the OSI layers only. It's not from anything else. But we will try to shrink the number of layers that exist that we see in the latest slides also. So this OSI model defines how do we transfer the data from one system to another system or one system to many systems in terms of the data security or complete data transformation, whether it is the half duplex or it is whether it is full duplex or who has to take which kind of the responsibilities and all those things. These are very, very clearly defined in the OSI models. We'll just see it actually. So probably this slide you might be knowing already. We have 7 clear OSI layers in the model. So the bottom layer is the access media, that is the physical layer. So the physical layer, when you come into the physical layer of the IoT, then we have a lot of physical layers or abstraction layers that are happening in the, because basically this IoT is nothing but sensors and all those things sit at the bottom of these OSI layers. So if it is the basic LDR sensor or temperature sensor or Ethernet or some other thing, so we need to take care of these kind of things. So that physical layer is a must to develop an IoT architecture. So without the bottom layer of the physical layer or access media, we don't have the IoT at all. And then coming to the next above layer is the data link layer. It's the packet formation actually. It's like more before sending the data to the abstract layer, we make the data linking is happening properly. So in some of the cases, we may have or we may not have the data link layer. Okay. And then coming to the above layer is that is the network layer and transport layer. This is a must to have the IoT protocols because the data is transmitting, most of the cases, the data is transmitting over the IP networks. That is the TCP IP network. Probably we may be using the IPv4 or IPv6 based on that is based on our design and architecture principles. But we need to have the enforcement of the transportation layer and network layer here for the IoT architectures to be implemented. That's very, very important here. So, and then coming to the above layer is a sessions layer, established connection. That is session layer is also some of the cases very, very important because it's like whenever we have this OTP kind of the things and all those things, we will establish these sessions so that some intruders, if comes in between, then we can cut off the things and then we can restore these things. So it gives us some kind of the data security also. That's why we maintain the sessions layer also. In some of the IoT the protocols, we may have the built up this sessions layer. That's very important. Then sessions layers and all those things, in some cases it comes with the cyber security kind of the concepts also, because IoT doesn't exist on its own. IoT is a part of a complete ecosystem. IoT comes with the AI, IoT comes with ML, IoT comes with the big data, because this is complete ecosystem. So this ecosystem, if one thing is not there, then other things will not exist at all, because the complete system has to have it. That's very important out here. Okay, please remember that point. So IoT don't look at the standalone model kind of things. It's not a standalone. It is integrated with the AI, ML, and big data. But that's how the industry is getting transformed into the latest better way. That is best for them, because instead of working in standalone mode, if you work as a eco partner of other systems, then the growth and stability is little bit better in terms. Okay. And then coming to the another top layer, presentation layer, that is where we take up the most of the cyber security, that is the encryption and formatting. And another, apart from that, we may take some kind of the precaution measures, how do we present to the user also. But generally that will be taken care by the application layer. So that is it. Then when we come to the topmost layer, that is the application layer, it is the data generation. And most of the IoT protocols right now, what we see out here is either they were used in the application layer or the network layer or transportation layer actually. So the communication, the basic today's topic is, when we're talking about the communication protocols are happening at the network layer or the application layer. We'll just see it how it gets established in the next slides. So this is some kind of the reference when we talk about the TCP/IP. So you can see it very clearly. So all the left side you can see some kind of colors, that is a OSI layers, and the right side you can see the TCP/IP stack. In between we have some kind of the protocols listed actually. So from the bottom side it's the Ethernet, Wi-Fi, BLE, LoRa. And all these things it will come under the IoT kind of the communication mechanism actually. So and one thing is, we cannot say it's Wi-Fi and LoRa and Ethernet alone forms the IoT communication. IoT is being derived from the embedded systems actually. It's not it's just some kind of, IoT is some kind of the catchy word to me actually. So earlier we used to call this as the embedded systems, which is there for the last 4 to 5 decades. So the embedded systems has got transformed into the IoT. In terms of why it got transformed into the IoT, so that's one of the reason is because now internet is available at an affordable rate, and affordable security levels are there, and it is available throughout the world very economical way. That's and penetration is also very high. So that's why this embedded system has got transformed into the IoT, and now IoT has become a catchy word actually. And another best part is embedded system is a point-to-point kind of the communication and all those things, whereas IoT is a little bit more enriched with more technical features, and it has the usage of the high-level languages. It has the many kind of the library support, and open source is also very strong support is coming up from the open source. That's why IoT is started getting into the development phase very fast. So when you look into here, actually, the bottom is Ethernet, Wi-Fi, BLE, LoRa. These are very important. All this comes under the IoT communication part. Apart from this one, we have some kind of additional kind of the communication, like Bluetooth we have, that is also part of the IoT. And in the Bluetooth, we have the Bluetooth with the BLE, that is the Bluetooth with the low energy, that is also there. And RFID communication is there, that is also under the bottom layer. RFID is most of the used. I'm planning to give one demonstration using the Arduino board and RFID for today's session. Maybe at the end of the session, we'll just see it, how the time is possible. And then we have the CAN protocol. If you look into some specific boards from the rugged board, a company called FITEC that is based out of Germany, but they have branches in Bangalore also. So that is, they are equivalently developing a product called a rugged board on competitive with respect to Raspberry Pi. But surprisingly, that board supports CAN protocol also. So not only this, that's why you can say it's Ethernet, Wi-Fi, BLE, LoRa, RFIDs, and some embedded communication is also very much required here. That means we need UART communication, we need SPI communication, we need I2C communication also. Because IoT is a part of a auto, is coming up very, very fast in the automotive industry. That is, especially in the cars and bikes, they are using heavily this IoT. So there we use dedicated kind of the systems like SPA and I2C and CAN protocols. We'll just see it in the coming up slides also, because I'm planning to cover that one. And then coming to the above, as I discussed in the previous slides, we have the IPv4 and IPv6 as part of the network layer, and transport layer is TCP, IP, TCP and UDP. TCP is the transmission control protocol, and UDP is the data control protocol. Okay, and then coming to the top is we have the HTTP protocol. And the top, we have the HTTP protocol and FTP protocol. These are the commonly web-based communication protocols. Apart from this one, we have the additional IoT related protocols. That means these protocols are developed very, very recently in the last 7 to 8 years only. Those are called MQTT protocol, and COIA protocol, and AMDAS protocol, and WebSocket programming also. So I will just discuss briefly about all those kind of the communication protocols. Even though our time is very, very limited, I will try to give the basic idea and introduction part of all this kind of this stuff, so that the next first part can be carried out very easily for you actually. So, first, let me explain you what is the IoT architecture, so that we can understand the things a little bit more broader way. So when you look into this one actual left side, you can see the end nodes. These are we call it the end nodes or edge devices. So the probably end nodes is being replaced by the a term called edge devices. So most of the people are calling this as edge devices. That is nothing but the sensors and the actuators and microcontrollers and all those things. And this is not with respect to any particular kind of things. This is a broader, so we can imply this architecture to any kind of the microcontroller. Whether it could be the Arduino or Raspberry, or it could be a Beagle Bone, or it could be FITEC rugged boards, anything we can apply for it. So this is the basic architecture. So left side you can see the it's a dual communication we'll be having, and in between, in middle, we have some kind of the gateway communication, that is a network kind of the stuff. So some of the things is how do we transfer the data? It's a network and a router, we can say it's. So we need to connect the end nodes to the outside world. How do we connect it? We can use any kind of the routers, either simple routers or a little bit expensive routers like from the Asus and all those things, or dedicated leased lines like fiber cable and all those things also we can use. So how do we transfer the data to the outside world? That is more important with respect to the middle kind of the block actually. And the right side, you can see the integrator, that is IoT platforms, cloud computing, data management, data science, visualization, analytics, web and mobile application. So this is the way we will have the cloud interaction actually. So the cloud means the data centers are located somewhere, but we have the authority to penetrate into that system, to go into the system, develop our own kind of the applications, deploy in it, test it, and deploy it, and anybody can use it from anywhere. So the right part, that integrator is very, very important. Right now, what we have in the world is there are a lot of cloud-based tools are available like AWS, Azure, and all those things. Apart from all those things, there are some dedicated cloud tools are also available, like ThinkSpeak, ThinkSverse, Kavi, and WebNMS, and all those things. And those tools are very, very specific to the IoT kind of the ecosystem, because their business motto is very, very limited actually. They don't want to go into the like normal database applications and banking software and all those things, especially the cloud tools like ThingsWorks, ThinkSpeak, WebNMS. These guys, they are more, and UA dots, and these guys are more dedicated to the IoT. So I will try to show one demonstration using ThinkSpeak cloud tool, and that has come from the MATLAB Simulink company. So the things will be a little bit easier. I will try to give the demonstration with that cloud. So this is about the basic cloud architecture. So earlier we have seen a little bit in more general terms. So now coming to the little bit more technical terms. So if we specify the architecture in terms of the more technical terms, so you can see how the derivation is happening. So we have we have the physical layer at the bottom is the end nodes. They are nothing but the lot of there. You can see there are a lot of devices that are connected, like water meters. We have smart watches. We have smart lamps. We have energy meters, and you have the voltage. You have the electrical power supply meters and all those things. So all these things we can call it as the edge nodes. That's how we will define it. So when you refer back into the OSI layers, it's all there in the physical layer actually. So these are the physical kind of the systems where the data is being transmitted from those physical devices through the wires or through the wireless, through some kind of the invisible format. So the data comes to the up, that is the above layer. So the Bluetooth layer or LoRa layer or Wi-Fi layer or GSM GPRS layer or RFID, whatever way we define based on our, it takes that data in terms of the protocol definition. This is what we call the protocol actually, communication protocol. This definition and all this, it will transfer the data based on expectations to the above layers. So then we can see the above layers, you can see the ThinkSpeak. So I have derived here, it's more that tools that are derived in the data stores and cloud platforms in this diagram is more dedicated to the IoT related, like ThinkSpeak, Xively, Carriers. These are the dedicated IoT tools for the cloud purpose. Okay, and then coming to the upper, there is another dramatic kind of the things are also happening in the world actually. So once if we have these kind of the cloud data also, there are a lot of interesting cloud tools are there where AI and ML will be played more active role. So these are the visualization that those things are described in the above layer, like IBM Bluemix, Amazon AWS, and Windows Azure and Salesforce. And these guys will use some kind of the machine learning algorithms or AI algorithms and predictive analysis. What these guys will do, they just take the data out of all these bottom layers, and they will, because it's a huge data, right? The data could be generated for every 15 seconds or for every 1 minute or so, whatever our program defines. So when we have this huge data, we cannot just pump the data to the end user as it comes actually. It doesn't have any meaningless. So we generate some kind of the commercial interest and commercial obligations and commercial applications on this tool. And so that the data will be useful in terms of either it could be predictive analysis or it could be some kind of presentation mode also. Let us take an assume if we record the temperature of the humidity, temperature and humidity of a particular location. Let us say in Bombay, we have recorded for the last 3 years. So all the data will be stored in the data centers of either AWS based on the commercial agreement or Azure and all. So they do some kind of predictive analysis and they will kind of give some kind of information in coming days, like in the last 3 years, the data is the data was like this. So you can expect rainfall in this kind of the period, or you can expect some kind of the high temperature during this kind of. So all this data gather and data presentation will be happening in the top place. That's more important because we cannot jump it. We cannot pump the data in terms of the raw data to the end user, weather department and all those things. So what this weather, let's assume that these weather departments, they will just give some kind of the graphs. Last year it is like this year it is going to be like this. They just give some kind of the presentation, very neatly in presentation, so that we understand things as an end user. We don't want to know about what is happening inside. Like, as an end user, we will understand things in a better way. What is the forecasting and what has happened in the earlier also. Similarly, also when we want to have the presentation to the either electric meters or energy meters and all those things, we can present into we can expect the future, what is happening also, so that when we are planning for the next year, like budget and all those things, we know where to allocate our budget funds, where to allocate our departments, and where to allocate the resources, so that the corrective action, we can be prepared for the corrective action to avoid the untoward incident that may happen in the lost. That's why when you have seen that one, that because of this global warming, there is a lot of unprecedented rain, like cloud bursting and all those things are happening. Even the cloud bursting and all those things are happening nowadays. This weather department across India or across the world is becoming very technically enthusiastic. So that they are giving forewarning to the concerned department and concerned people, so that they can avoid the at least loss of life. Forget about the properties. At least we can save a lot of lives by migrating people from that location to that. So all these things are happening with support from this kind of the technology. So okay, and then in the top layer is applications, web and mobile. So we can present it to now. Everything is available either in it is available in the web format or in the mobile format. Same thing, because the mobile penetration is so huge that not have the laptops or computers at every department, and in all the data can be viewed using the mobile itself, so that mobile industries can also have this support to this kind of the IoT. So this is the basic IoT architecture. Let us move on to the our more communication protocol stack actually. So this is what we discuss a little bit more deeper into the communications. So here, what if you look into the here, what are the different layers that physical layers that we have here? Ethernet, LoRa, Wi-Fi, Zigbee, GSM, NB-IoT, Bluetooth, 4G LTE. These are the predominantly active right now. So in future, we may see a little bit more like LoRaWAN. LoRaWAN is coming up very fast, even in India also. So there is the internal competition is there between these layers also. Based on the commercial accessibility, we can install the specific kind of the link layers. It need not be all the things, or need not be one thing also. We can have the choose. So that's why there is a proposal that IoT gateways are also, so very soon it is going to happen. IoT gateway means, so now if you look into any network, any router, the router supports only IPv4 or IPv6, any router right now, either it's domestic kind of routers or commercial routers. So probably in the down the line, you will see the IoT gateways. That means the routers can be embedded with the RFIDs, with the GSM technologies also, if it has independent, and the Bluetooth also, because the research is happening in that way also. That means the router, at that time we don't call it a router, we call it IoT gateway. So IoT gateway is also on the roadmap. Maybe it will come in the next couple of years. A lot of big companies are investing money to get the product as part of the IoT gateway rather than normal routers or normal gateways. So it is also on the way. Okay. And then coming to the network layer and the transport layer, TCP, UDP, we have discussed this in the previous slides, and IPv4 and IPv6 and LoWPAN we have discussed also. Okay. And then coming to the top layer, this is very, very important. Here, as I discussed earlier, as we have the HTTP protocol, that is the web-based protocols, and coming to another protocols, we have the listed here, MQTT protocol that is dedicated to the IoT kind of things. So most of the things are very recently developed communication protocols. That's why very, very important. So MQTT protocol is the open source protocol. Anybody can do it. Anybody. It has the whole protocol layer. Quality of services are there in the MQTT protocol. We will discuss in the later point also. So similarly, we have the CoAP, that is the constraint application protocol, and XMPP, which is another protocol, and WebSockets, DDS, and AMQ. These are the more kind of the IoT communication protocols that we are using heavily in the subject. So this is a simple gateway, how it looks like. In the left side, so right now what is happening in the market, the commercial market, if you look into that one, so 2 decades before, there are a lot of PLCs installed around the process automation. Too many, all the things are equipped with the PLCs. So the PLCs may come from the Siemens or ABB or GE or Mitsubishi or some other kind of companies actually. So it's a monopoly industry. It's mostly 67 companies are there who manufactures real PLCs, and Chinese are also entered along the last decade. So these PLCs, they invested huge money into it. It's millions of the dollars. Now there is immediate work is happening on these PLCs, which manufactures like scooters, assembly. It's like assembly floors. Scooters, cars, or it's a process automation, means it's cement industries, glass manufacturing industries, or whatever. It's a very big manufacturing industries which are semi-automated. So these things are having huge requirements. They have to get upgraded to the next level or coming up generation. That's what we call as the industrial IoT, Industrial 4.0. Industry 4.0 is nothing but the implementation of the IoT into the existing process automation. But process automation is very, very difficult because they have their own standards across their own domain. So we cannot just enter into it. As I know that, as we know that I know technically, I can come down and I can implement this kind of technology. No, it's not possible with respect to industry, as they have their own specific domain standards and all those things. We need to understand their standards and specifications and what kind of things. So we need to tweak these IoT technologies according to their need, and then only we can implement. That's why there is a lot of struggles happening, a lot of connecting issues and complaints issues are happening between the IoT technologies and Industrial 4.0. That's why probably you might be seeing that, but there is a lot of pushes happening, but it's not moving. Why it is not moving? Technology is available, but still these people are using the Ethernet technologies, and still these people are not having the Wi-Fi communication and all those things. Why? Because they need to consider a lot of additional parameters. Like if you have any industries like Maruti or Hyundai company or Ford company or GE company, so they cannot give the data just like any other industry to put on the cloud. It's not possible because they need to understand the data security and the data privacy also. Otherwise, they cannot leak the data because these are the competitive rival industries. So they go a little bit more carefully and they will analyze the parameters with respect to their domain constraint also. So all those things you can see out here actually. That's why, but there is a huge work that's coming up. Maybe in the it might be open around 2023 or 24 as per the industrial expectations. Once the 5G rolls out, then the data rate, data transmission rate is a little bit faster, and the bulk data we can store it in within affordable rate. then the industry 4.0 is going to pick up a little bit faster. That's what the industry big guys are expecting. So that thing may for 5G may come around 2022, that is in the next year. So it may take one more year. By 2023, industrial 4.0 may take the revolutionary steps across India or more outside the world, the India also. Okay, that's very important to note of it. Okay, so now we have seen some kind of the communication protocol in application layers. I discussed like MQTT. Apart from that one, there are some more communication protocols are also there. These are already there for quite a long time. These are called embedded communication protocols like VRT, SPA, and I2C. These are the communication protocols exist from quite a long time. Apart from this one, we have the CAN protocol also. I have not listed out here because CAN protocol is a little bit more expensive. It is not supported by the many IoT devices except rugged board of IoT. Okay, so probably you might have heard about this UART, SPA, and I2C. So all the automotives, cars and all those things, they use SPA communication in a lot of things, and I2C also. So how do we define the serial peripheral communication interface, SPA? How do we define? This is very important to just aware of the things. So serial is a complete duplex synchronous serial communication. It's just used for the short distance communication because that's why when you look into this SPA and I2C, they will be used in shorter communication. You have the in a car, you have the EMC, that is the engine. You have the electronic device, controller device. The controller device has to send the data very fast to the either brakes or oil leakage, oil sensing kind of unit, or some kind of the what do you say, display system and all those things. So there they will use this kind of the SPA systems. So it is most of the embedded system communications are used for the shorter distance only. It's not for the longer distance. Because this is also very important. Why we are taking this one? Suppose you take any car and all those things. Nowadays, there's a connected car concept is coming up. So how do you find the location of the car? So based on GPS location, GPS is also part of this kind of thing. IoT. So this is very important. So I just discuss. So let's go into the little bit. Spend a couple of minutes on this SPA. This is serial peripheral interface. It works with the master slave architecture. So that's one of the best thing that we can say in the SPA. That means with the one master you can control the many devices. So that's why this in the course we have this kind of the SPA communication. Some guys will go for the SPA communication, some guys will go for the I2C communication. So one device we can connect as the master, and other things can connect as the slaves. So that gives a very good. And how does it connect? It has the 4-wire bus, and it requires 4 wires to communicate. And SPA can transmit data continuously without interruption. It doesn't have the start or stop bits. So in other scenarios like UART or I2C, the data communication happens with a limited number of data bytes and all those. SPA communication is used to many devices like memory ports and RFID codes and all those things. That way you can say it's like special purpose. Say when you suppose when you are we have the memory card, right? Normal memory card. So our USB memory, how do we dump the data using the SPA communication only? It's as simple as that one. So somebody has written the SPA device driver into that one, and they just put it. So it has a specific address system, and you just it identifies the USB is inserted in that. It starts whether what kind of the action you need, what then we can say it's dump the files from this to that one and that to this one, the fully duplex one, then it will just. So SPA communication to understand more, all the memory ports are coming up with the SPA communication. So SPA device drivers are there, any kind of ports. So that's how we can understand it. So as I told you, how do it's a 4-wire communications. So we have the master out, slave in, and master in, slave out, and system clocks and all. These are the basic things that we can have in SPA communications. So how fast it can send data right now, it has the limitations also, but they are increasing actually. Its max speed is 10 Mbps and synchronous and theoretically unlimited actually. So probably you might be getting the question in some of the cases, the data transfer rate is very, very fast in micro codes, micro SD codes. How it happens, say, more than 10 Mbps. So so when you look into this SaaS company, actually they are creating additional layers to have a little bit better speed also. So the one of the best thing that why we are discussing about this SPI is supported by the IoT devices. So I have listed it's a what do we call it's some kind of screenshot of the BIOS setup of the Raspberry Pi. So when you give the command sudo raspi config on the Raspberry Pi, so you have these kind of the different kind of the buses that are there in the Raspberry Pi IoT hardware. I think you might be already knowing this Raspberry Pi. Generally, we use the Raspberry Pi 3B plus or 4 Raspberry Pi 4B with the 4 GB. So my strong recommendation is if you are using the Raspberry, go with the Raspberry Pi 3B plus, which is very, very stable, and then go with the Raspberry Pi 4 GB actually. So both are same actually, not much. So if you want to go for, you can go for the Raspberry Pi 8 GB also. It's a little bit expensive, a little bit additional 2000 you need to spend, but I don't see much difference with respect to 4 GB and 8 GB. So here I just displayed a BIOS screenshot. What are the different things that are available here? You can see the SPA and I2C both are supported actually. So that I just want to highlight that point. That's why I just given the screenshot of the BIOS setup of the. So, but we don't have this kind of the BIOS setup for the Arduino boards because Arduino is a very, very beginner level. So, till my recommendation is the IoT subject and all those things are starts with above Arduino actually. Arduino is just learning things for the in-house kind of stuff. For the Raspberry, when we have this operating system, we have a lot of things to do it. Okay, so this is how it happens. So if for a practical for students or the ready to practice in-house setup, you can connect the Raspberry with respect to Arduinos. You can connect any number of the Arduinos. You can have the addressing system. You can do the addressing system from one as a Raspberry as a master unit and Arduino as the slave system. So we can prove this SPA concept here. And then coming to the another embedded communication protocol, this so as we discussed I2C, this is also very, very important. So it is also a synchronous serial communication protocol. It follows the similar kind of the master slave kind of the mechanism. It is also used for the short distance. But the important point that is different from the SPA is I2C is having the 2-bit addressing sequences. That is, you have the 7-bit addressing system here. So you can assume that when you have the 7 bits, you can connect up to 2 power 7 devices here. And we have the 10-bit also. That means you can connect up to 2 power 10 devices also here. And the difference between SPA and this one is this is a 2-way communication. So there we have the 4-way communication, but here we have the 2-way communications. But the another difference is I2 is a little bit slower when compared to the SPA actually. SPA is a little bit faster. So I2 devices can communicate with respect to 100 kilohertz or 400 kilohertz. And it has the acknowledgement and negative acknowledgement also. So that's why in some of the automation sector, they implemented I2C. So now slowly this automotive sectors, they started getting rid of this I2C because they expect a little bit faster actually. So I2C is not supporting as per their expectations. That's why all these bench cars, these European German cars like Volkswagen and all those things, they migrated from the I2C to the CAN protocol. So that's why we can say CAN is going to come very, very fast in terms of the IoT when we have this. So there is a transformation is also happening in terms of the communication protocols. which are having more complex in nature and more stable in nature than the present one. So it's continuous evaluation. So here advantages is here we use only 2 voice and it supports acknowledgement and positive acknowledgement and negative acknowledgement. And the hardware is not that much complicated and very widely used. And disadvantages, as I told you, that it's a very slow data transfer than SPA. So when you want to transfer the data with the faster, you go with the SPA. And when you want to have the slower data, go with SPA. It's just pros and cons for any kind of the communication protocol. Okay. And size of data transfer is limited to the 8 bits and more complicated hardware is needed to implement this. Okay. Just to be aware of these kind of 2 communication protocols, which are very important. But because we can do a lot of impractical applications also. Like we can connect a Raspberry, one Raspberry, we can connect to 6 to 7 Arduinos. And whatever the concepts or POCs, proof of concepts that we hear about it or we read about it, which needs more budgeting to prove the concepts, we can do all those stuff using Raspberry and Arduinos because the budget doesn't cost more than 50,000 actually. If you buy 5 to 6 Raspberries or if you buy 10 Arduinos also, the budget will not cost more than 50,000 to prove this kind of the concepts. That's one of my point. That's why we can say it's a in-house just to prove the concept, how it works, whether it really is working or not. We can do on this one, then we can go for the higher level with the things also. The industry goes in the, it will take the temperature sensors is available right from the 350, 300 to 250 to 300 onwards. So the in-house we use the DHT11 temperature, which is around 350 rupees something, and DHT22. Same temperature sensors are available for the 30,000 also, which gives it a more accurate and reliable. So they are the industry graded also. So they passed all the QCs and industry graded electronic PCM, ECA and EMC certification methodologies. So that difference we need to understand. Okay. So these are the voice used to, and it's a little bit slower. Standard mode is 100 kbps and faster mode is high speed and automatic and synchronous and serial and parallel master slave. So 1,000 maximum number of cells because we have given the 2 power 7. So you can see in there, this is also I have taken the screenshot from the Raspberry Pi. The screenshot is the I2C actually. So what we do, we need to enable this one manually. We need to enable that. Otherwise, by default factory setting in the Raspberry is it is in the disabled position. So we need to enable it either through programmatically or through the click method actually. So we need to be aware of these things. And then we move on to the cloud-based communication protocols. So when we talk about these cloud-based communication protocols, all these protocols exist at the top layer. So when we talk about the OSA layers, on these layers, how do we packet the data together? How do we acknowledge it? And how do we ensure that the data has been transmitted properly or not? All those things, sessions maintenance and presentation maintenance, and all those things has to be taken care by the application layer. So bottom 6 layers, they don't care about it. So in IoT, when we talk about it, when we implement IoT specific kind of protocols, whether it could be HTTP or MQTT or OAP or web sockets and all those things, then it is our responsibility to implement all those things with respect to specific standards. Otherwise, it goes for toss. So that's why when you look at here, there is some kind of dedicated port numbers are also used. So when we have this kind of the design and architecture for the hardware and all those things, we agree we deserve a lot of port numbers for the future use. So the great guys have designed in such a way that when they made around 20 to 30 ports empty whenever we are designing the hardware. So one of the port that is available is the 80 port is for the HTTP that has come very recently. FTP port is 22 At the same time, MQTT protocol is also used, 8080 only they use, and these all these remote control procedures and all those things, they use the port number 22 because they are the dedicated. Because so when they have given some these bottom physical layer developers, that's hardware players, when they do they're given just some kind of scoping for the application layers. So whenever you are designing application, all those things, these are the packet port numbers so that you can transfer the data to this one, so that data transmission and data security can happen in proper way. So that's very, very important to know it. So let us see about the HTTP protocol. Probably you might be aware of this one. It's a hypertext transfer protocol, because this is very, very important. All the communication protocols, so it has to follow this kind of the standards. IoT and all those things will implement this one very, very clearly. So when we write when we do the programming in edge devices on the Raspberry Pi or Arduino and all those things, we define some kind of the data where to send the data. So let us assume the case of the data, say in a simple case, a temperature and sensor. So temperature and sensor, when you got the data from sensor device, physical device, you need to send the data to the cloud applications. Which cloud applications? There are so many cloud applications. Every cloud application is having its own address. How do we find the addresses? Using the HTTP protocol, and they have the domain name, and they have the web page, web address, and port number, and all those. Using that one, we can identify it. So all those things has to be embedded into the edge devices. Otherwise, it cannot understand where to send the data. So if you are trying to use the HTTP protocol, we need to implement all those things here. So that's why we need to know about it when we are designing the IoT protocols, and IoT edge devices and all those things. We need to be aware of what kind of the communication protocols that we are using. Are we going for the HTTP alone, or are we going with the MQTT protocol, or are we going with the web protocol, or we are having the redundancy also in our system, so that if one system is failing, we can take back into the next alternative route also. That also we need to define. So that's why this HTTP protocol is a web-based protocol which transfers the data from one system to another system in terms of the application layer. So IoT edge devices, sometimes IoT edge devices maintains the HTTP protocol also. That's the way. So Arduino, if you look into the Arduino, they have a lot of additional Python-based libraries out there. All those things has to be included in the Arduino. Whereas when it comes to the Raspberry, you not do it because it's a Raspberry is having its own Raspberry operating system. So we should not worry about it because it has its own support. So how does it? It's a statelessness. It has a metadata transfer. It's a handshaking kind of the mode actually. Request response mechanism transaction is initiated. So when you have that kind of the data, when you initiate the data, so it goes to the server and server gets back. So it's a client server mechanism. So HTTP happens at the higher layer and it has the client server model actually. And we have these URLs here, HTTP, that is the uniform resource identifier. So that thing we can see it. So I'm planning to give one kind of the demonstration here. So here in one of the demonstration that I'm planning to do it in maybe another 15 minutes. We don't use any specific kind of cloud tools. We are using our own kind of the loopback mechanism. That is our own IP addresses. So that we can see it very, very clearly that it has a multiple kind of the implications when we have these kind of HTTP characteristics. So next, coming to the POAP, it's another kind of HTTP protocol. It's a constrained application protocol. So when do you use the constrained protocols? It's like embedded kind of a system. So when you have some dedicated systems, So there is a more secure kind of if you want to have the data security and the data privacy, then please go with the CoAP because it has the constant kind of the mechanism. So the communication happens across the nodes only, and it has the dedicated channel. Like if you have the, let us assume the case, the VPN, virtual private networks, how it goes with respect to CoAP only it goes actually, because it has to have a lot of dedicated, because the protocol definition is quite different. So the CoAP is an application layer protocol and follows it is also similar kind of, most of the application layer follows the request response kind of the one. That means you client server model and requesting, you give the response. It's as simple as that one. So it won't go beyond that. So it has you can see the CoAP protocol specifications in the RFC 7250, and it follows the similar kind of the things. So this is how it acts when the CoAP application is implemented in the mobile. It sends the request and the server will respond to it. So instead of here, you can see it protocol format, how it looks like. So here it won't have the HTTP in the beginning, it has the CoAP. Generally, we use in the constant application. Normally, it is not open outside actually. So because it's everything is dedicated. So you can see in the prefix, it's a CoAP, not HTTP. So, and how do we get the data, the APIs and all those things? To make it a little bit more unique among all these application protocols, we use similar kind of the keywords like a get, post, put, delete, and to utilize the data to send or to get back. So we use the same kind of the APIs like a get, post, put, and delete. So we have another web sockets. This is also application programming. So this is also two-way communications. This also follows the client server model, and the data is being exchanged in full duplex mode. It's a part of HTTP. Some people will use the WebSocket as part of the Java programming. So in the Java programming, this WebSocket programming is being implemented heavily to have that one. So you can say it's the similar kind of handshaking model that we use here. So, so you can see that this WebSocket will use a keyword like a WS in the beginning. So we have the HTTP as the keyword, and we have the schema, we call it, and the CoAP, we have the CoAP, and we have WebSocket, we have the, there's some kind of the implementation that we do. It's the WebSocket architecture. So probably I will share these slides later, you can go through. And then coming to the another important cloud communication protocol is the MQTT protocol. I strongly recommend this MQTT protocol right now because it is being heavily used by a lot of applications. It is being why it is being heavily used right now. All MQTT servers across the world are free of cost. So the mechanism to develop and all those things are very easy here. So all the home automations that are using the MQTT and all the automation process right now, they are using the MQTT protocol heavily. Even when you look into the WebNMS and all those companies also, they started depending on the MQTT protocol actually. Because another big thing that we have different here is we have the QS and quality of service QS. I will just spend some time, a couple of minutes on the QS also. So this is one of the very important. Generally, either we go to the HTTP protocol. Generally, in the normal, in my experience, I have seen people are implementing either with the HTTP protocol or MQTT protocol in the application layer when it comes to the IoT. So they don't go beyond that one actually. So they specify the following. It's the initial goals of this MQTT protocol it should be very simple to implement, and it should provide better QS, and it should be very light, and bandwidth, it should not take more bandwidth, and continuous session awareness should be there actually. So this MQTT protocol, how it works is it works in the publisher subscriber model. So here you can see it's there is some kind of the left side. You can see the temperature sensor is there. So this temperature sensor will send the continuously data as per the program to a broker, MQTT broker. This is what I'm saying. MQTT brokers are there throughout the world, installed by the big companies for the free of cost, because it's their job is they have their own specific addressing system. So we need to know about their addressing system actually. How do we do it? These temperature sensors will continuously send the data to the MQTT broker. Temperature sensor, this left side is we develop. This is called publisher actually. We publisher. Left side, that is called publisher. And we'll, as a publisher, we'll send the data to the MQTT broker. MQTT broker is having a subscription model from the subscribers. It's like a normal, any kind of thing. It's like a subscriber means it's any Gmail account or any Outlook account. We subscribe to that one. When we subscribe it, then they will be continuously, when there is an updation is there, they will immediately send up updation to our email ID in terms of the newsletters, right? You might have seen, you might be receiving newsletters on everyday basis, what is happening there and this and that. Similar kind of concepts here also. When we subscribe to that MQTT broker with respect to particular kind of publisher, then it will start sending the data when there is an upgradation is happening. At that publisher side, it will immediately send that just data to this kind of this subscriber. Actually, the subscriber could be mobile or laptop or computer or any computing device, even it's IoT device also. It could be of any IoT device also. So it's I assume that it's as simple as you are subscribing to a newsletter actually. When you subscribe it and there's an upgradation, it starts sending. So that's a newsletter, some kind of text format. Instead of that, here what we have is the real-time data, the real-time information. So, and here, because it has to take the data immediately, and the action has to follow it very, very immediately. Assume that one. There's a in process automation, when you go for process like cement industries and all those things, there are a lot of boilers will be there. When you have a lot of boilers, temperature sensors are attached to it. When the temperature is exceeding to some certain level of the threshold one, immediately it starts sending continuously data to this the broker, and broker is sending the data to the subscriber. And subscriber will give some kind of alert mechanism saying that one, that particular boiler is crossing the threshold level, please take the corrective action immediately. Then this subscriber, who is there, who is in management position also, immediately he will alert the concerned people saying that one, either you need to shut down the system or you need to take some corrective chemical action to reduce the temperature of that particular boiler so that things will be under control. So who is doing all those things? It's just MQTT protocol. We can implement this MQTT protocol either in the universities for the examination process or for any commercials. It's quite heavily, it's becoming a very, very popular. Another best thing is, okay, there is a lot of open source libraries are available with the MQTT protocol. Everything is available in the GitHub. So you can go into GitHub, you can dump any publisher kind of things, you can start tweaking according to your requirements, and it will start working. And it's as simple as that one. It doesn't take more than a week time to develop a MQTT protocol or to tweak the existing MQTT protocol to our needs, provided requirements are very, very clear. Okay. So this is also works like any kind of systems client. We have the client is always expecting the data when we have the some upgradation from the broker. So it is always in the listening mode, and if in the listening mode itself, we'll take the corrective action if it's supposed to have. And then we have the broker, as showed in the previous section. It's a broker is always acting as a intermediate node between the publisher and client or subscriber. So you can, client is nothing but subscriber. Please note that one actually. So it has a dual communication. So broker is also, so these brokers are maintained. So what are the different kinds of this? As I told that MQTT protocol doesn't take much time. We have the APIs or the parameters that we need to take care of is very simple. You need to take care of the client ID, client session, username, password, last will, and all those things. These are the things sufficient to handle this MQTT protocol. And the MQTT protocol, as you see, it's in third point, this the QS service is available. So this is very important for any network developers, like transport layers developers or because they just list the quality of the QS service of that communication protocol based on their level actually. So the same QS level is also supported in the MQTT protocol. It is not there in HTTP or it's not there in the OAP, but MQTT is. So in the QS, we have the three kinds of services. So we have the 0 QS 0 and QS 1 and QS 2. It's 2 actually. So in the QS 0, what happens is where messages are delivered according to the best efforts of the operating environment, messages loss can occur. So QS 0 is free of cost. So right now, all the QS 0, 1, and 2, all three are free, but we cannot expect the things free of cost for the longer time. Maybe they'll start charging from the coming year onwards for the at least QS 2 actually. So in the QS 0, the data may be lost. If the data is lost, then it becomes our responsibility to send the data again. But when you use the QS 1 at least once, that means where messages are assured to arrive, but duplicates can occur. So you may have multiple messages, but duplicates. So in QS1, it may happen. Whereas the services of QS2 exactly once, where the data is being transmitted only once and it is delivered also very clearly. So QS2 is going to be a little bit more costly. Right now, all the three are free, but slowly they may put the QS2 as the chargeable in coming up days. Is a primitive kind of the service because they're spending a lot of money for this the server maintenance. Okay. And MQTT client of normal disconnector. So we have the last will and testament also. So we have this kind of the features also: keep alive messages, will messages, retain messages, and durable subscriptions. So how long the message should, if the client is not responding, what should we do it? We send the data again, or we should kill the data if the client is not responding. So all those things can be taken care by keep alive, and will messages are also sent, and the retain messages and the durable subscription is also comes into the similar kind of things. So how do we do it? So there are a lot of there are a single kind of the APIs are available. Like connect, disconnect, subscribe, subscribe, publish. These are nothing but the methods of some case we call it the APIs, application programming interface. So by using these methods directly, you can start using because it is derived from the Python programming. Python is also has come from C++. So we have the objects and methods here. By deriving an object, by creating an object, by having any methods, we can directly start making use of it. So what are the for the publisher? These are the different kinds of the methods that we have. And subscribers, we have these kind of things. And the QS, as I told earlier, we have the 0, 1, and 2. 0 means the minimum level is 0 and it guarantees best day effort delivery. So it may miss the data. 0 means it may miss the data. Generally, don't miss it may happen. But when we have the QS services 1, at least once, definitely it is going to send. But a duplicate may arrive actually. And QS2, definitely it's going to. So as I told earlier, there are a lot of brokers are available throughout the world. So these are the left side given around 5 servers names. So we can start using these 5 servers and the broker name is given very clearly. It's a mosquito broker against each server actually. And these servers are maintained with big companies. So far, initially they plan to give the free of cost research till March 2020 only. Because of the corona, they extended by a year. So it went up to the March 2021. Now they have extended it till March 2022. So till March 2022, all these servers, all these brokers are available for the free of cost. Afterwards, we don't know right now. Because these guys who are managing these guys, yes, they have to say it because already they are investing a lot of money on this maintenance of these servers. These are the big servers located somewhere in the world. We don't know where exactly it's located. So you can use any kind of services. Any use Musto, you can use IAV, MQ, Musto, Mosca, IAV. So right now, the current version of the MQTT protocol that is running around the world is MQTT 3.0 version, 3.0 version is going on. So that's very, very important. Another important thing we need to know about is here we need to use the port number as the 1883 only because these are the very, very dedicated ports. Like earlier we have seen the if it is the FTP protocol, then we need to use the 22 as the port number. So it is dedicated to the FTP protocol. If it is the HTTP protocol, then we need to use the 80 as the port number because these are the hardware defined kind of things. So we need to define these port numbers inside our programming, then only communication is possible. So that's why I have listed that one. It's very, very good to have the to have our past guys have predicted the requirements of the future and they left some port numbers for the free of use, free from usage at that time, and so that future guys can be implemented. So these are the another protocol is advanced messaging protocol. Is also an application protocol. This is also the similar kind of the protocol. It is having similar kind of the properties like that of the POA, but it's more kind of the what do you call it? It's a handshaking mode only. So, but not many people are using right now because the existing itself is more occupied by the MQTT protocol and HTTP protocol. And for best, it is going to use mostly in avionics kind of things. I believe so actually. But right now, MQTT is not used by many guys, but just for the future purpose, I have listed out here. And then we'll just spend another 10 minutes on this. What are the different kinds of the IoT platforms are there? And then we move on to the demonstration. Okay. So the session may go a little bit beyond 4 o'clock. I hope it is okay for the participant. So now we start discuss about so far we discuss about the communication protocols, traditional communication protocols, embedded communication protocols, and then application layer protocols. And then coming to there are a lot of platforms out there like cloud services and all those things. So these are also when you look at the architecture, basic architecture, right? Say you have the all listed cloud data, cloud computing services, AI-based services, ML services, and big data concepts, visualization concepts, and predictive analysis, and all those things. These are all maintained by the cloud services, actually. How do we use the cloud services and all those things? That's very, very important to know it. So we'll just, how do we select what are the top IoT platforms that are there right now? These are the AWS, Microsoft Azure, IBM, Bluemix, Salesforce, Google, Cisco, ThinkWorks, these are some of the IoT platforms. Apart from this one, we have ThinkSpeak and WebNMS and all those things are also there. The problem with this dedicated IoT platforms is they're not too good in the user interfaces. So of course they have the user interface, whatever their requirement. Whereas when you come to the AWS and so these are basically Windows kind of they have the record of the Windows software development who are too good in UA and UX, so they can present the data in more beautiful format. At least for the eyes, I can say it, not from the data perspective, and the different kinds of data graph modes and all those things. Similarly, Amazon also does the same thing. Whereas I don't count it because we don't need it. We just need pie chart or some kind of lateral charts. So how do we select it? We need to understand how can we manage the devices. What are the securities that are there? Is it easy to deploy the things across the AWS or Azure or ThinkSpeak? We need to understand, and how much data analytics it supports, and how do we integrate it. That is also very, very important, because sometimes the AWS is supporting EC2 support, and EC2 is okay, but whereas integrating with others is very, very difficult. So third-party application integration, we need to understand whether they are supporting our MQTT protocol, whether they are supporting HTTP protocol. That's where we need to understand very. And then in the last visualization dashboards, IoT is too good actually. Visualization dashboards, now it has become a very, very popular. So people are, because of the Python availability and R programming availabilities, people are developing the visualization software like anything actually. Of course, there. And then business experts, platform stability, we need to understand, and pricing models and support. And we just spend some time on this cloud, what is the cloud and all those things. So the cloud means we have the internet, connectivity, we have the network. It's as simple as that. So how do we connect it? Either through the public or private kind of things. So the cloud can provide services either public way or private way, or WLAN way, or LAN way, or VPN way, based on pricing model and subscription model actually. So, but please be aware of it. Cloud services are more expensive when compared to the dedicated IoT platforms. So the normal AWS services, if you use a device, it will cost you around 20,000 rupees. One device I'm talking about. One device I'm talking about. Whereas the same thing, if you use the same by using ThinkSpeak, you can spend around 47,000. You can use for 1 year. 1 year you can use actually. So you can just start comparing the pricing model. Pricing model of this cloud tools like I said as well, quite expensive when compared to dedicated IoT platforms. Please be aware of it. Otherwise, we're spending too much money on these cloud services, which we are not using really on practical ones, because we are not into that kind of banking software or tax, that kind of things. We are there going data, real-time data. So what is cloud? Cloud computing is delivery of the computing services, servers, storage, databases, networking, software, analytics, and more. So this is so all things when you look into it, probably you might be knowing that one. When you go into the AWS cloud services, suppose if you develop a software using the Windows environment, but you want to test it on Linux environment, but you don't have the time and to install the Linux, start doing testing, and you don't have the specific kind of the architecture, hardware architecture to test on it. What we can do it, we can immediately hire the cloud services of this AWS and all those things. Start deploying or migrating or porting our code, which is running successfully on the Windows onto the Linux model that is there on the AWS, and start doing the testing. So we do not buy additional kind of the hardware components and software components. So but we can hire using the cloud kind of the services. So these are very, very important even for the IoT also. So suppose if we develop a software on the Raspberry, so it is working fine. But the client has asked, no, I don't want my software to be working. But I have the PyTech based edge nodes on my client side. So please be tested on the Raspberry developer code onto the PyTech code, whether it supports or not. Then what I do, then I don't buy any PyTech code again. I'll just hire a subscription model from any cloud computing tool who will give me support for that one. I will just run the same software, because that PyTech might be supporting different kind of the Linux, different kinds of that, and I will start redoing the testing. If it goes everything, then I will start delivering, or I will tweak it according to his needs, and I will transfer it. That's a very, very important to note down it. So when you want to hire these cloud tools, then we please be aware of this one. What are the costs? What is the speed, global scale, productivity, performance, and the reliability. Otherwise, we will be spending more money than what we are supposed to. Okay. So here we have the different models. We have the deployment model, service model. These are the two predominant models are there with respect to cloud. So we can choose any of the things. Deployment model defines the type of the access to the server, how the cloud is located. Cloud can have any of the four types. So the deployment models we deploy there, we don't take services at all. Take the service at all. It's we take the complete responsibility of ours. So this deployment, that means we have our own team also, cloud team also we have with us. So our cloud team will do the deployment and will do the delivery to the end client. So here in the deployment also, we have the four different kinds of the models that we have. We have the public mode, we have the private mode, and we have the hybrid mode, and we have the community mode. I will just briefly explain of all these things. So what we need to do, so what are the advantage of this kind of the deployment model is data availability and continuous uptime. So it works 24/7. So you can start working on, so your first team can work in morning, second team can continue the same working with the second shift and all those things. We can, or across the regions also. The guys can work in India and the evening times the US guys can work on the same continuous also. So on-demand scalability, it's available 24/7. So you should not worry about it. All the data is available on cloud services. We should not worry about it. And easy also inexpensive. So inexpensive. So we not buy hardware and the software services also. Software dedicated for, if it is one small project, then we not buy for small project the expensive kind of the spending lakhs of the rupees on the operating system and different sizes. So we can start hiring for number of hours. And then no wasted resources. That's okay. And then the dessert what is that's very important. What is the data security? What is these are the two things that we need to take care of before getting signed into the cloud services of any cloud. Okay. So the cloud is allows systems services to easily accessible to the general public. So it's like broadcasting kind of things actually. So it's like a weather and all those things. Public cloud may use less secure because of it. So examples, the AWS, Google API, Salesforce, and these. And if you look at the Gmail, it's a public kind of the services they have maintained. Of course, they have the one authentication model. So recently, there's a lot of hue and cry is there. That's why these Gmail guys, they have adopted two-factor authentication like OTP authentication and all those things. Since this is a public cloud. So we need to aware of this one. But please remember this, AWS can support, is having support of the public cloud, private cloud, hybrid cloud, and community cloud also. So it's just like pricing model. It pays for public cloud is a little bit cheaper actually. So private cloud is a dedicated kind of things. The system allows one service to be available within an organization. It's more secure and compared to the public, and it has a dedicated extra layer of the protection, and it is accessible only to the only certain kind of the privileged people, not all the people. So advantage is privacy within the organization. If it is one organization, they expect one private cloud, so that the data can be under the control, especially data is under control. They can ship the data outside of the network, it's not problem. Whereas in the public cloud, it may happen. We don't know actually. So privacy in organization, private cloud provides more security, and the major drawbacks privacy is at the higher. When we have the private clouds, obviously it comes with the higher price. Okay. And community cloud, it's also similar to but infrastructure and competition issues are these are the exclusive to that one. It is some kind of the derivative from the private cloud. So in the private cloud itself, there is a top high-end testing team is there. The testing team needs more dedicated kind of the expensive hardware. Then we can have the community within that private cloud itself, rather than team where they will be accessible to the high-end, more expensive hardwares and softwares. So the cost of setting up combination cloud services in the private can be cheaper due to the division of the cost. And a lot of additional tools are also available under the actually. So, and cost is, when it comes to the disadvantage, the cost is very high, and fixed amount of bandwidth and data storage is shared among the expenses. And the last one is the hybrid cloud. This is the deployment. So it's like mixing of the clouds. So wherever it's like a cocktail kind of stuff actually. So we can mix public and private. We can take one hybrid cloud. And so if there is a big team is there, around 30 members team is there, 15 users are allowed to the private and 15 users are allowed to the public, something like that. So it is a mixture kind of things. It has a similar, it is derived from, it's just a cost-based model actually. So they are deriving. So here you can see it's how it looks off-premises public cloud, off-premises on-premise, you can have the private cloud. Premises means when the people are working from home right now, you can see a lot of people are working from home. So off-premises, so they can be accessed with the public cloud. So, but when they are working on premises, they are to the private cloud. So you can see the example. But in the public cloud, then you may have a question when we have the public cloud, do we have the security issues? Yes, we have the security issues. That's why when the people are working from the last 2 years, almost one more than 1.5 years, when work from home concept has come after this pandemic situation. All IT companies are provided this VPN connection irrespective of their designation. So everybody has to log in through the VPN connection only, unless they don't, they cannot just like log in because it has to have the security, because it has to be monitored and controlled by dedicated kind of services. That is the best advantage. So it's more scalable in terms of that it contains both private and it offers both secure resources and scalable public resources. It provides always highest level of security as it has been designed for private cloud. It can reduce and manage the cost and based on the requirement. And the disadvantages, communication in the network level may be conflicted as security may breach through the public if it's not used properly. That is also there because always cyber, that's why cyber security concept is come. So there that one deployment services and service. Next coming to the service models, we just spent a couple of minutes on service models. So it's a similar kind of things, but it has a different kind of it all depends on pricing models. Infrastructure as a service, platform as a service, and software as a service. So what are things that you need? You need either Windows services or Linux services, or what kind of the Linux services, or if it is Autos means you need VxWorks, you need PSOS, you need VMware. So all those things we can hide it. So based on that so on-premises, IaaS, PaaS, and SaaS we can. So I will share this slides. Probably you can just go through it. You can understand it very, very easily. So what are things when we have this service models means what are things that we can take the help from the company actually, that is cloud service. And it could be AWS or it could be ThinkSpeak or Google or UKDOS, what are things. And they have provided the infrastructure as service, what are things that so we need to understand little bit internal details also. And so when we are taking help of it, there are a lot of dedicated platforms out there for each kind of the domain. So we need to aware of those kind of things. We can hire the platform services also. And then we can hire the software services also. That means specific software services like VPN services. We can hire VPN services. And then nowadays, so you can see these VPN services are becoming very popular actually. And commercial sales also started coming out. So you can have the single user, you can have the multiple user, and you have the dedicated laser connections also. All these softwares are VPN connections as a normal home user. So when you are doing the bank transactions from your home, so you should not, somebody should not see you don't know who is seeing your data and all those things because you have taken the ISP services from the general kind of the either ACT fiber or Geo or something. So they can see the data. And what is the best way that you can do it? You can have this software as a services or like VPN service. You can buy this the VPN services either from the Express VPN or Nordic VPN. You can install on your mobile and all those things, so that all your data will be happening, a transfer will be happening through the VPN services from your mobile. It could be your mobile or laptop service. So all your bank transaction data, or if it is income tax, or even if it is personal, can be traveling over the tunneling kind of the mechanism. VPN is nothing but the tunneling kind of the mechanism, so that your data cannot be seen by some other guy. Actually, it's more secure as of. So when you have this one, it's a mix of the things. All these guys are using the cloud, so you can see it. Everything, most of the things here listed out here is public clouds, just for understanding. And so, what are the use cases of this one? Applications, streaming audios, backups, websites, blogs, analyze your own kind of data, developing dashboards and all those things. I will just share this one, but I don't discuss about this one. It's AWS and Azure also. So you can go with this one. So these two guys, these are right now, these two are dominant in terms of the cloud services, AWS and Azure. Of course, Google is also coming up heavily. But for IoT perspective, I don't see it. But if you want to have the visualization and all those things, then you can take the help of this AWS and Azure. Okay. Now I will go with the demonstration. First, I will give the demonstration of a simple application that is an RFID. So I think you can see it in camera. I have already connected everything. This is the RFID. This is the RFID, and I'm using the Arduino board here. I will connect here. So the basic, it's a very simple one. The basic, so what is the use cases here? I have the smart cards, like two smart cards and one keychain. This is all three are smart cards, you can say it, and it has the unique code. Please hold on. I need to transfer the data to here, and I need to switch on the screens also. Please bear with me. I will share some other data. It's just compiling. I will, after demonstration, I will try to show the code also. Okay, I will just share some other. Okay, probably you might be seeing my screen, another screen, which is having the UIDs and some already is there, access denied and all those things. And I demonstrate this one. This is the smart card. I don't know this what is this unique ID, but what I will do is I will just place this one near to the RFID that I have shown to earlier. Okay. Let us see on the screen what will happen. Authorized access. Oh, so this means this code is accessible. Again, I will show it. Authorized access. Okay. I will just hold this one. And this is another code which I showed you. And I will try to swap this code. I will place it, this code near to that one. Okay. So this is denied. So this is denied. So this code is accessible and this code is not accessible. And I will show this is the another blue color keychain RFIDs, and I will display, I will show this one to the RFID. So this is also denied. So this is also denied. So in this one, what we have is we have only one code. Only this code is having the accessibilities. Okay, right? So authorized access, only authorized access. So this is the simple application. So in the shopping malls and all those things, they will use this kind of application only. Very easy to develop. So you can have the SP implementation also, I2C implementation also using this one. And it's very interesting, even for the students and all those things, we can have a lot of types. So that's how this one, it's very inexpensive. I can say it's very inexpensive, not spend time at all. Okay. This is one of the practical application I want to show it. Simple RFID accessibility. Okay. We can make it even more complex. The same thing is I used Arduino, only I have used. Okay. The code and all of those things are here. So I will just share the code. So this is the code. This is the software. You can see the MFRC 522. This is the code that I have developed. So here what we did, you can see in the code content not substring 67B2B1 of 4D. This is the ID of specific kind of smart code which has the authorized access. For other codes, I just said it has the access denied. It's as simple as that one. Okay. I think hope you like this one. We will move on to the next one. Next one I'm started showing is measuring temperature and humidity using the DHT11 temperature using the Arduino, okay. I will just show you the device. After capturing the data, I'm transporting or exporting the data to the cloud-based tool. So here what I am using is, here I am using a cloud tool called ThinkSpeak. I like this tool a little bit more because four channel, we have the four channels for the free of cost. So for the random experiment, we can do it on experiment basis. After four channels, if you want to buy, you can buy it for spending 47,000. We can get additionally 100 channels. Here, these people will call it channels. So I just created for the demonstration purpose a channel here. This is the channel. Here you can say it. This is the temperature and humidity channel I created, and each channel is having its own ID, channel ID. You can see it here, channel ID, and the accessibility I just put it as a public, and the demo is just demo version. And I created a couple of years back. So right now you can see it's the current live temperature of my room or my lab. Here out it is displaying. So here you can see it. We created two years ago. The last entry has happened less than a minute ago, and the entries are 60. You can see it probably here. You may not see it because of the online kind of, because you can see entries is increasing by 1 inch. Just hold on it. You will see it. Yeah. Now you can see entries is 61. So this is because the units are presented here. It's today's actually. We can say it's a GM Monday. It's not Monday actually. It's very difficult question. Yeah, now we can see it's because we need to increase the scaling actually. It's a humidity is 82 and on November 23, and at the time is 16.4. That is, you can see it. When I putting the tip here, it is shown. So this is one kind of the widget. Now you can see the entries are 62. This is one kind of the widget. Now if you want to have the better widget also, these guys are providing some kind of the small kind of the widgets. These are the things that we have. So the correct is some kind of meters. So the current humidity is here in my lab is 82 and the temperature is around 27. So you can see it here like this. Or you can have the digital format also. You can create, because these guys have provided a lot of opportunities. Add widgets. So the way you like, and you can upload the data to the your own YouTube channel also, because the YouTube channel detects your geographical location with the help of the Google Maps. So Google Maps identifies the location where you are uploading the data across the location, and it will start uploading the data to it. And the best thing is there are guys out there who are really selling this data also. So if somebody needs it, okay, temperature and humidity is quite easy to do it. If there is some data, some kind of data, you can upload it to this one, and you can make it to the commercial also. That's where we say it's a public means anybody who is using ThinkSpeak can see my data. But if I make it as a private, only the guys whom I have given the authority, they can only see the data. So now you can see the entries. Entries are 65. So that means since for every minute it is getting updated. Since we started around 5 minutes ago, 5 entries have recorded, because I am exporting the data on minute to minute basis, because we cannot export data for every second, so usually huge data. So every minute I am exporting the data. So the data is coming up here like this actually. It's almost, so here you can see less than a minute, so it's accurate. So the best thing is, and how about the data security? It's absolutely good. If somebody wants to access the data, he cannot access the data without our permission. How do we control it? Here, these guys are providing the API keys. So these are the API keys. So the guy who wants to access our data, he has to use our API key, that is read API key. Unless he knows this API key, he cannot access our channel data. Who gets this data? It's only me who has to supply this key actually. This is the encrypted data. So if you want to generate new API keys, you can generate by clicking on this one, it will generate, it runs a small algorithm. So which generates some kind of the new keys. So every time, suppose if you get doubt that somebody is watching your data and all those things, you just generate the new API key, then these keys will get changed. Uh, then your data will be, your channel data will be more secure. So this is also one kind of the cloud data, cloud tool. The same thing, even AWS also follows the same way, and Google also follows the same way. Probably they will be having some different kinds of the graphs and all those. The data is going to be the same, but the presentation manner is a little bit different. But for that usage, we need to pay a little bit higher to those guys actually. That's the difference that I can say it. And it supports all kind of the communication protocols. It supports HTTP protocol, it supports MQTT protocol and all those things. The best thing I can say is you can develop your own MQTT client and just ask for the read API keys of this one. You can directly take the data from ThinkSpeak Cloud, because this is a global tool actually from ThinkSpeak. You can download the let us assume the temperature and humidity on your MQTT client. You can see it. That's the best way I can say it. So you have the support from all the here. You can take the help of it and all those things. And the best thing that I like is, so from my personal side, why we go for this is the MATLAB, and these guys are supporting. This tool has come from the MATLAB and Simulink guys actually. So obviously, when we have this kind of the scientific communication together, then we have a lot of supporting network to each other. Actually, that's the best way I can say it. You can go as per your wish, but I strongly recommend from my side. And it's very easy to develop also. So, okay. So you can see the channels, my channels. I'm just using it for free of cost only. Demonstration, I have the 4 channels, demonstration, temperature, and humidity. And the CPU temperature also unmeasurable time to time actually. And it's a self-explanatory is there. So you can see here examples and all those things are there. So 4 channels, as I told you that 4 channels, if these guys are giving, ThinkSpeak is giving for free of cost. Beyond 4, if you want, you need to purchase for commercial use. Okay. That is more of industrial usage actually. They don't sell 1 channel or 2 channel. They sell 100 channels actually. So what do we use? That's how it is. Okay. So I'm stopped. I think we'll just see it in public. So the current data is, you can see it. You can just see it. Is it 74? So we started with the 60, almost 14 minutes have passed. It seems so. So now you just see the data is getting streamlined actually. Temperature is getting streamlined. See it. So it's around 26 or so. I have the temperature in my room. So, so this is the one. So now I demonstrated temperature on the cloud. Okay. Then how do we do it? You can see it. I will just take the help. You can see it in camera. How do I attach it and all those things? Yeah, this is the mechanism that I have. Arduino board I have used, and I connected with the phone bank actually. It's a power bank. It's a power bank. So I'm as a power source, and here I have the ESP8266, and blue color one is the temperature module. So ESP with the, so I am used Arduino with the ESP8266 to export the data to the cloud. It's as simple as that. Okay. So I will stop this demonstration here, and then we move on a little bit more advanced. That is, I developed one more thing. It's for demonstration purpose. That is also displaying the temperature and humidity, but we don't use any cloud, commercial cloud or third-party tool. We use our own Python developed dashboard. That means I developed a small tool, a small dashboard kind of stuff actually. It's for in-house development only, so that we not spend money on this one and source control, and because since it is the open source kind of, because I develop and we use open source. So we have everything in our control. If we want to have the MQTT can develop. We want HTTP can have. We want to provide support to the 4 devices, we can do the 4 devices. If something suspicious on security is happening, then we can change the keys and all those things. So we have that kind of the mechanism. Not only that one, we are planning to develop some kind of small kind of the data center also here. That's why we are using the SQL database on the Raspberry Pi. So that thing I will demonstrate right now. Please go on. So I have scanned my network actually using the Angry IP scanner. Generally, I use that one. So what are the systems that are up right now in my system, in my network? Is in this room is only 2 systems are up. That is my laptop, that is the installation, and another system is RAS 13.local. You can see it in the, and third one is I guess that is my mobile. Actually, my mobile is also having one. So we have the 3 systems up in the network connected. So we need to identify the system with respect to IP address because we don't have the implemented DNS mechanism yet. So we just go with respect to IP addresses. So the best thing is Raspberry is running somewhere. I will just show it somewhere else. I just kept it in corner of the room, and it runs on 24/7 actually sometimes. That is attached to the different EPS so that it should not get disturbed. So it actually, it's a little bit far away from here actually, because that's near to another socket. I will just show it after the demonstration. So what we are, since we are having our own kind of the open source web browser based tool actually. We can say it's a web browser tool. That means we can have our own cloud tool. How do we go it since we didn't implement any DNS kind of mechanism? We can just go with the IP addresses. That is IP address here. The Raspberry IP address is 192.168.1.5. So we just now what we do, we just open the so I think probably now you can see the my Edge, Microsoft Edge web browser. It's just like any client actually. I don't want to. We can use any web browser client. It could be Internet Explorer, it could be Chrome, or it could be Edge or Opera. Anything you can do it. So now I'll just type the IP address of my Raspberry Pi. That is 192.168.5. So this is the IP address which I sent a HTTP request to my Raspberry Pi. So the home address is that it's just welcome to, it's a title. So what I will do is I will just go with this one. Then I will go with I have these things. This is the lab page. This is another web page that I have created. That means it's my own cloud, my own small data center. It is coming up slowly. So this displays the temperature and humidity on any web browser. So you can connect to my network and you can access the temperature and the humidity. And at the same time, You don't need any third-party paid tools or free tools. You can use normal web browser to access the live temperature and humidity of this lab actually. So this is as simple as that. So I'm not spending money anything on purchase any third-party tool. And moreover, since this is the open source software and all those things, I have better control over kind of the communication protocol that I need to have, what is the time interval that I need to give, and what are the buttons that are here. I didn't implement any dashboard kind of things so far, but it's coming up slowly. We are planning to have one kind of the dashboard, and the data can be implemented. So we have what are the things that we have seen in ThinkSpeak, similar the kind of the graphs and all those things we want to implement out here. It's already under the process actually by using the Google APIs or some other APIs. We are just verifying the data. So after getting implemented, we can see all the graphs and stuff. The data like this text format, you can see that. And this data is getting updated for every 10 seconds. You can see it in the top of things. It just scrolls back actually. You can just see in the top, it just scrolls, just make a rotation of it. Yeah, that's it. So this is this is as simple as that. It's I'm using DHT22 temperature and sensor just to get an input. Right. So how do we do it? I mean, just try to postpone because a lot of files. So I'm going to show it actually. This is the Raspberry that I have attached here. This is which it has one kind of communication mechanism and all those things. This is the Raspberry Pi that I have. Dedicated system. This is a 10-inch monitor that I have attached here. And we have the DHT22 here. DHT22. DHT22. So this is everything is attached. So it is the live, that's what we would say. 4x7 live. Okay, so the data gets transmitted for every 10 seconds. You can refresh because it's already implemented. Database is also implemented, so it gets refreshed. So these are the three demonstrations that I want to give it so that you can develop your own cloud also. You don't buy it. Otherwise, so just to use the EC2 of AWS or ThinkSpeak for 4 channels. Beyond that one, no need to spend more money. It's very quite feasible. If you have developed your dashboard using the Python and everyone, then the source code and everything is under your control. Should not worry about it. Okay. I will stop here.
Thank you, sir. Thank you once again for your wonderful presentation, sir. So your presentation such as IoT architecture, IoT simplified architecture, IoT protocol stack, IoT connectivity model, serial peripheral interface, feature of I2C, cloud-based communication protocol, MQTT connection, IoT platform trade-off, and more importantly, ThinkSpeak, which which tells you that IoT analytics platform service that allows us to aggregate, visualize, and analyze live data to the cloud. And finally, sir, your own cloud setup, which is really attractive. Thank you so much once again, sir.
Thank you.
Thank you, sir.
Thank you.
Thank you, sir. So now I would like to request our all participants, please kindly fill up your feedback form and send back to us. And this is the end of our today's session. Our next session will be start from tomorrow at 10:30 a.m. The link is already shared with you. That is the same link and at the same time. So please kindly be with us and connect at the same time. Thank you so much. Thank you.